All right, let's talk about hubs, switches, and routers. You've definitely heard these names before. In fact, I'm willing to bet you have one of these things blinking away in your house right now. So let's finally demystify what these little boxes, these fundamental pieces of our digital world, actually do.
I mean, really think about it. We connect to them every single day. They are the gatekeepers to everything we do online. But what's going on inside? What's the real difference between them, and why do you need one over the other?
Instead of just reading a bunch of dry definitions, we're going to do something a little different. We're going to build a network right from scratch. We'll start small, watch it grow, and see which one of these devices we need at each step. It's the best way to really understand the why behind it all.
Okay, so let's set the scene. Imagine we're in one room, and we just have 2 or 3 computers. All we want to do is get them to talk to each other, maybe share a file. It's the most basic networking problem you can have. So, where do we start?
Well, for this first simple task, we're going to reach for the oldest and simplest tool in the box, the hub. This is kind of the ground floor of our networking journey.
Now, the key phrase here is Layer 1 device. In the world of networking, Layer 1 is the physical layer. We're talking about the actual wires, the electrical signals, the nuts and bolts. A hub lives at this layer, which is why it has zero intelligence. It doesn't think. It just takes any signal that comes in one of its ports and blasts an exact copy out of every other port. The perfect way to picture a hub is to think of an old-school telephone party line. Where one person starts talking and absolutely everyone on the line hears them, whether the message was for them or not. That's a hub. It's simple, but it's incredibly noisy and inefficient.
And you know what happens on a party line when 2 people try to talk at the exact same time, right? It's just chaos. You can't understand either of them. In networking, we have a name for that, a collision. The data from both computers gets all jumbled up, and they both have to stop, wait a moment, and try to send their message all over again.
This brings us to a really critical networking term, a collision domain. When you use a hub, your entire network, every single computer plugged into it, is part of one giant collision domain. So the more computers you add, the more shouting and the more collisions you get. Everything just grinds to a halt. It works for our 2 little computers, but you can see how this is not going to scale. So clearly, that party line mess is not going to work as our network gets bigger. We need a smarter way to manage the conversation. And that brings us to the next step up in our evolution, the switch. Now, a switch is a massive upgrade. It operates at layer 2, which is the data link layer. What that really means is that a switch is smart. It can actually look at the data passing through it and make an intelligent decision based on something called a MAC address, which is just a unique serial number that every single network device has. Let's upgrade our analogy. If the hub was that chaotic party line, a switch is like a really efficient mailroom clerk in an office. This clerk doesn't just stand in the lobby and shout, "I've got a letter for Susan." No, the clerk knows exactly where Susan's desk is and delivers the letter directly to her and only her. Nobody else is bothered.
So how does it know where Susan's desk is? It learns. It builds a little address book, kind of like this table. The very first time a computer sends a message, the switch sees it come in on, say, port number 10. It peeks at the sender's MAC address and makes a little note. Aha, this computer lives on port 10. Over time, it builds a complete map of the entire office. So that's the process right there. It listens, it looks at the source, it builds its table, and then it forwards things intelligently. And here's the game changer. Because of this, every single port on a switch becomes its own private collision domain. The collisions are gone. Our office network is now incredibly fast and efficient.
Okay, our office network is running like a dream, but now we need to do something new. We need to connect to the outside world. We want to browse the internet or send an email to a totally different company. Our smart little mailroom clerk, the switch, can't help us with that. And here's why. Just imagine for a second if the entire internet was just one massive switched network. It would be a complete disaster. It would collapse instantly. The mailroom clerk analogy totally breaks down when you have billions of desks. And the reason for that collapse is something called a broadcast.
A broadcast is basically a message that's intended for everyone on the network. Think of it like a company-wide announcement email. Now, for all their smarts, when a switch sees a broadcast message, it only knows how to do one thing: forward it out of every single port. On an internet-sized network, this would create what's called a broadcast storm, a never-ending flood of data that would bring everything to a screeching halt.
And this right here is the #1 reason why routers exist. A switch is great, it solves the collision problem, but only a router can solve the broadcast problem. It works at layer 3, and its primary job is to create boundaries between networks so that those broadcast storms can't happen.
So to finish our analogy, if the switch is the office mailroom clerk, the router is the city's main post office. The post office doesn't care which desk a letter is going to inside a specific building. Its job is to look at the address, see that it's going to a different city, a different network, and put it on the right truck to get there.
Okay, now in the modern world, this is where the lines can get a little blurry. You might hear people talk about something called a layer 3 switch. So what the heck is that? Is it a switch or is it a router? The answer is kind of both.
Here's the simplest way to think about it. Layer 3 switches are mostly used for routing inside a large local network, or LAN. Think of a big company that needs to quickly move data between its different departments. They have lots of ports, and they're fast. A traditional router is more of a specialist for connecting your network to the outside world, the Wide Area Network, or WAN, also known as the Internet.
But really, let's just cut through the jargon. At the end of the day, if a device is making decisions based on layer 3 information, like an IP address, it is performing the function of a router, plain and simple. The term layer 3 switch was honestly a brilliant marketing move to make routing sound as fast and cheap as switching.
Well, we did it. We built our network from just a couple of PCs sitting in a room all the way to a business connected to the entire globe. We've seen exactly what problem each device was designed to solve. So let's wrap it all up with a quick final summary.
It all boils down to this. The hub, our layer 1 device, simply connects things. It's our chaotic party line. The switch at layer 2 is much smarter. Its job is to direct local traffic. That's our efficient office mailroom. And finally, the router at layer 3 has the biggest job of all, connecting different networks together. That's our central post office. Each one is a step up, an evolution that solves a new problem as our network gets bigger.
And so I'll leave you with one last thing to chew on. That all-in-one box you get from your internet provider, the one that sits in your living room and gives you Wi-Fi, now that you know the layers, what do you think it is? Is it a hub, a switch, a router? Or maybe it's all three of them, cleverly crammed into one little box. Something to think about the next time you see those lights blinking.